Okay, I think we're on the air now. So hello, everyone. Everyone that's joining us online. I've got some Santa Cruz folks here as well. So what I'm going to do today is I'm going to switch over to sharing my screen, and I'm going to walk you through a tutorial that I put together. This is the second time I've walked through the tutorial. So if anyone's interested, there is a recording available. I've posted a link to it on various mailing lists like the Peacock mailing list and some of the mailing lists here in Santa Cruz. So the content is pretty much the same between the previous tutorial, but what I'm going to do is just go ahead and go through it again. In the future, I'm also going to have like more advanced tutorials where I talk about stringing together multiple tools and workflows using CWL. And then also launching them in cloud environments. So look for the announcements on those tutorials in the coming weeks and months. Okay, so hopefully everyone can see my screen okay. I'm just going to go ahead and put this into presentation mode. So I'm going to start the tutorial with some slides to give you a sort of overview of what we're doing. And then I'm going to go ahead and move on to the actual tutorial. All this content, the slides and the tutorial itself are available. I included links in the description of the Google Hangouts on Air. So you guys should be able to get to those and follow along with me. Okay, so just as a background for those of you that don't know me, my name is Brian O'Connor. I'm the Technical Director of the Analysis Core here at the Genomics Institute at UCSC. And this work that I'm presenting, this tutorial on the Docstore, it's a collaboration. Most of the work was done at OICR as part of the Cancer Genome Collaboratory Project, and it was inspired by the work that we did in Peacock. Okay, so let me just go ahead and tell you about the overview of the slides I'm going to go through. So the first thing is I'm going to talk to you about why Docker is useful, what it does, why people really, really love it these days, and it's being used quite a bit in the IT world and also in our community in the genomics world. I'm going to tell you about context of how we used it in the Pan-Cancer Analysis of Whole Genomes project, which many of you online are associated with and working with. And then I'm going to tell you about how we're planning on using it as Peacock publishes its results and publishes its workflows. Then I'm going to introduce the Docstore, which is the project coming out of OICR and Santa Cruz and the GA4GH. I'm going to tell you why it's useful, what it adds on top of just plain Docker, and how it also fits in with the Peacock goals. And then I'm going to launch into the tutorial, and I'm going to show you how to create a tool in Docker and then publish that on Dockstore and share it with other people. And again, in the future, we may have a repeat of the same tutorial again in the future, but also I'll have a more advanced tutorial about workflows and executions at scale in the cloud. Okay, so what's the utility of Docker? I'm assuming some of you guys on the call today haven't used it before, have maybe heard about it. Shut the door. All right, thanks. So the thing that makes it great is it's a packaging tool. So it lets you take things like configuration files or workflow definitions or reference data and the tools themselves. The example today I'm going to show you how to use BAM stats. So it lets you take all these things and their dependencies and put them in a lightweight and highly mobile image. You can move it around to various Linux environments. It supports most recent Linux distributions, and it's very, very popular with the general IT community. So a lot of people use it for packaging up services and sending them around to different infrastructure. The nice side effect of that is there's many fantastic tools out there like Quay.io, Docker Hub, and many related sort of community tools to use Docker. So what were some of the applications? How did we use it for the Peacock project? So for those of you that are new to the Peacock project or don't know the background on it, this is a large international collaboration. It was organized by the ICGC. And the task that we had as the technical working group was to harmonize the analysis of 2,800 cancer donors worth of data corresponded to about 5,800 whole human genomes. So we wanted to run the same alignment and variant calling pipelines on that. And the trick was we had to spread the work around multiple storage sites all around the world. So there were 8 sites that we stored the data at, and we had, at our peak, 14 cloud and HPC environments that we were using for compute. So we needed some mechanism to send work around and to package up the workflows. The type of workflows that we were packaging up was a standardized alignment workflow and 3 best practice pipelines, one from Sanger, a joint pipeline between DKFZ and EMBL, and one from the Broad for calling somatic mutations. And then there was a downstream filtering and merge process. Many of you on the call that are associated with Peacock working groups are currently working through this core analysis variant data set. So how did we leverage Docker in this scenario? How did we actually use Docker to perform this core analysis across many sites? Not all of the 14 sites conform to this particular architecture, but many of them did. And the idea was that we had an upload process to populate our storage system. In this case, it was Genos for this project. And we indexed that storage system so we knew what cloud contained what data. Once we knew that, we were able to schedule out work. We knew, oh, this donor lives in this cloud, and we need to run alignment and Sanger variant calling, Broad variant calling, DKFZ, EMBL variant calling. So we essentially had folks called cloud shepherds that would take the metadata index and determine what needs to be run in what cloud environment and in-queue that work into what we called a cloud orchestrator. And that would automatically spin up VMs in that cloud environment and then run the workflow. So for these workflows, we ended up settling on a model where the workflows themselves were contained within Docker. And so that allowed us to spin up resources in a whole variety of cloud environments and run the same workflow, the same tools in different environments and get the same result. And we did that successfully for the Sanger, DKFZ, EMBL, and Broad pipelines over time. So how does Docstore and Peacock workflows and tools, how do they fit together? So as the Peacock core analysis is now finished and going through its final sort of release of the data to the various working groups, we wanted to take our workflows that we developed in Peacock and the technical working group, remove Peacock specific components like Genos upload and download. It's very specific to our project, and host them in a place that people could refer to them in their papers and use them for future analysis. So we wanted a final version of these core workflows that should produce the same result as our final filtered result so that other people could analyze their data in an identical way. We also want, in an ideal world, we'd really love to have folks in the Peacock working groups do the same sort of process for their tools. For the analysis that happens in these working groups that is published on, it would be fantastic to have a place, Docstore being that place where we could share those downstream analysis tools in a standardized way. And then finally, as we do that, we want to have a place that, since we use a standardized CWL descriptor and Docker for Dockstore, we want other systems to then be able to run these Peacock workflows and tools. And that's the ultimate goal, is we can publish, point to those tools, and then have other people in other systems be able to leverage and run them to increase our sort of sharing with the community. Okay, so out of this Peacock project, the Dockstore evolved. It was really inspired by the work that we did here. And the Dockstore is trying to solve 2 core problems. The first one, which is completely obvious that we needed in Peacock, which is the ability to take tools, put them in some sort of container, and move them from cloud to cloud, VM to VM, server to server, and get the same answer, right? So Docker provides that for Dockstore. It's our mechanism that we used in Peacock that worked really well, that we're using here as well. So Docker packages our tools. And the second sort of core problem that Dockstore is trying to do is to link Docker images, Docker-based tools with a descriptor. So one of the shortcomings of using Quay.io or Docker Hub or these other sites that exist right now is you can publish your Docker-based tools, but there's no standard for describing, like, this tool is in this Docker image and here's its parameterizations. This is how you call it. So for Dockstore, what we decided to do is use the common workflow language and the workflow descriptor language, so CWL and WDL respectively, that are metadata formats that are human and computer readable that describe how to call a particular tool or workflow. So that's what we're using for the Docstore and the two sort of core problems we're trying to solve. Now, Docstore, we didn't want to reinvent the wheel. There are some very good services out there already. I mentioned earlier that the Docker space is very active. There's a lot of cool things happening there. So our ultimate goal for Docstore is to bring together our CWL, our tool descriptor, with a Docker-based image and present that to the community in a searchable and nice sort of interface. But that doesn't mean that we have to recreate all the infrastructure. So for Dockstore, the tutorial I'm showing you today, what we're doing here is we're leveraging GitHub as our place for storing our descriptor that builds the Docker image and our descriptor that tells you how to run it in CWL or WDL. So we're storing that in GitHub, and then we're using Quay.io to then take that Dockerfile, that descriptor of how to build the Docker image, and automatically build it. So Quay builds the image, and it also serves up that Docker image. And what Docstore is doing is it's really acting as a lightweight registry that brings together those two things, the tool in the Docker image that's been built by Quay, and then the descriptor that describes how to call that image from GitHub. So as part of doing this, we've been working very closely with the GA4GH to establish this registry as an API standard. That way we can have many other sites implementing what Docstore is doing, and we can share the tool definitions in the same way. So Docstore is a reference implementation of this API. Our goal is to have other sites implement that so we can do cross-site indexing. So on Docstore, you can see the contents of other tool registries, and other tool registries can see our content. And it's currently working its way through the containers and workflow task team of the GA4GH. Our goal is to have an API standard sort of ratified before the end of the year. Other standards that we're working on is once you've created a tool, put it in Docker, and described it with CWL, how do you execute that at scale? So that'll be the content of a future tutorial, and the group is also working on API standards in that space as well. Okay, so at this point, I'm going to switch gears a little bit. I'm going to off my presentation mode, and I'm going to switch over to the tutorial itself. So let me scroll to the top. So this tutorial, and before I do that, I should also check to see if there are any questions, which I don't see in this. Okay, give me a moment. Let me check to see if there are any questions from the group. Okay, so I don't see any questions right now, so I'm just going to dive into the tutorial, and I'll answer questions towards the end of the tutorial. Okay, so again, the URL to this is posted in the Google Hangouts on Air, and also keep in mind this tutorial will be recorded and posted on YouTube as well. Okay, so this tutorial, it's available on the Docstore Get repository under our wiki. You can find it there, and eventually this content will migrate into Dockstore.org proper. Okay, so prerequisites. I'm not going to go through the creation of all the accounts that you need, but I am going to point out that in order to get started with Dockstore, you'll want to have a GitHub account and a Quay.io account at the very least, and I provide links to those. You'll also want to, once you've established these two accounts, you want to go to Dockstore and log in with your GitHub account and link your account to Quay. Alternatively, you can use Bitbucket and you can use Docker Hub, but what I'm presenting here is GitHub paired with Quay, because that's slightly better supported on Dockstore because Docker Hub does not have an API, whereas Quay does. So it's a little bit easier to use Quay through Dockstore.
Is this sensitive to using our personal or UCSC accounts for those various things?
Everything that's on Dockstore is a public repo. So in the future, we'll support private repos, but for now, it doesn't matter if it's your own personal account or an organization that you're a part of. If you're part of the organization, then you can publish a repo that's associated with that organization. Okay, so as far as the development environment setup goes, I've successfully run this on my Mac at home, on my Mac here at work. This will allow you to do development locally. You could even do development on a Windows box, although I haven't tried that. I know that Docker does support Windows. However, what I'm recommending is I recommend most folks stick with an Ubuntu 14.04 development environment. Again, as long as you can get these dependencies installed, you can work on different Linux environments in Mac, but I'm really recommending that you stick with Ubuntu 14.04 just because that's the one that's best tested. The dependencies, the versions of the tools that we're going to need are linked here, so you can follow the install instructions here. And I've just displayed out on my development host. This is running on Azure, and it's an Ubuntu 14.04 box. I've just listed out the particular versions that I'm using that I know work. So hopefully that'll be useful information to you. The other thing I'd recommend too is as you're working with Docker files, which describe how to create a Docker image, and I'll show you an example soon, you may want, if you're working locally, you may want a nice editor. I find that Atom is a pretty good editor for it. So something that does syntax highlighting. Okay, so just coming back to this image just to orient us into what we're trying to do in this tutorial. So what we're trying to do is we're trying to set up our Dockerfile and Docstore.cwl on GitHub, link it to Quay to build your Docker image, and then register the two of them and show that you can run it from Dockstore. That's the goal of this tutorial. So the first thing that we're going to do is we're going to create a source repository. So I've gone ahead and done that already for my demonstration here. This is within my own organization, and I created a new repository, Dockstore tool BAMstats. Keep in mind, we're going to refer to this as a path in various configuration files. So make sure that your naming is what you want it to be referred as. So in GitHub, it's actually quite easy to create a new repository. Once you've logged in, you can just click up here, new repository, and it'll walk you through the process of doing that. The other thing I want to point out, and some people have already done this from the previous tutorial, is since this is intended to be a good high-quality example, you can go ahead and actually fork my repository here, make a copy of it in your own organization, and then customize it for the particular tool that you're interested in wrapping in Docker and registering on Dockstore. That might be a convenient way to move forward quickly. Okay, so the tool that we're actually going to focus on today is just BAMstats. It's a very simple tool that provides information on a BAM file and generates a nice HTML report. So it's a good first pass tool. The other thing to point out is if you have issues with GitHub, there is really good support documentation online. So I'd encourage you to take a look at that. So at this point, I've established my repository, and I'm going to add some files to it. So we're going to focus on the Dockerfile first. And here's a sample of what it looks like. I'm going to walk you through the individual elements of this Dockerfile. What the Dockerfile is it's basically a scripting file that the Docker tool runs through and runs each of these commands in order to create a Docker image. And this is the place that you're defining what that Docker image, that mini Linux environment, what software it's going to have installed in it, which of your tools it's going to have installed in it. Any sort of dependencies that you need are going to be added in this step. A lot going on here. Starting with the first one, this is indicating that I'm going to use the Ubuntu 14.04 Docker image as my base image. Now there's a whole wide variety of images out there in the world. You can find them by searching Docker Hub or Quay. I tend to stick with these guys because they're official Docker images. So these are images that the Ubuntu project has put out. And I really want to stick with that because I know they're going to be good about applying security patches and that sort of thing. If you're using someone else's Docker image as a base, you're not quite certain exactly what they've done in it. So I tend to stick with the official ones. The next section, you're just describing the maintainer of this Docker file, so it's good to provide some contact information in there. And the next section, you can see I'm doing several different things here. First of all, I'm switching to root because I'm going to do installs of tools. I'm going to do a run. So the prefixes are all available on Docker's website. There's amazing documentation there. There's a ton of good tutorials out there for building Docker files. But in this case, this is just meaning that I'm going to execute this line. And you can see what I'm doing here is I'm updating get and also installing various tools. And this is a common tip. Sometimes people will break these up into separate lines. What that means in a Docker file is each line is basically a layer of a virtual file system. You did an update in one line and then an apt-get install in the next line, keep in mind that because of caching, your update won't necessarily run. So you really want to combine certain lines into sort of logical groups of commands that you want to make sure all run together. In this case, I always want to make sure I do an update of get before I do the install. The next part, I'm just pulling back a binary distribution of BAM stats. I'm unzipping it, doing some cleanup, and then moving the BAM stat jars to the opt directory. So again, you get to decide all this. So this is one of the reasons why Docker is so powerful. If you were working in an HPC environment, in order to do this, you'd have to email, typically you'd have to email a sysadmin and have a conversation about the particular tools that you need to install, the particular dependencies, and there could be anything from a multi-day to a multi-week wait for you to go through the process of getting this available to run PC environment. So being able to do it yourself and to virtualize and put that in a little sort of container that can be moved around, it's very, very liberating. It means that you can create your environment that you need for your tools to run and have that be mobile. So that's an incredibly powerful thing to do with Docker. The next step, this is another important command. This step allows you to copy information from your Get repository. In this case, if I look back here, my bin bamstats wrapper script. It allows me to copy it from my source repository into the Docker image, right? So this is the mechanism by which you get information tools, source code that you want to compile into the Docker image. And then all I'm doing here, since it's just a shell script, I'm just going ahead and changing it so anyone can execute it. A similar approach, though, in other Docker files that I've built, I'll actually copy in entire source tree structures, and instead of just change modding it, I would do a Maven clean install or a make or other build process. So that's cool because you can actually control the build environment of your tool and actually the deployment environment as well through Docker. It's very powerful. Okay, so the final lines of the Docker file are just adding an Ubuntu user. And I do recommend that you switch to an unprivileged or lower privileged user within your Docker file. So what's happening here is I create the Ubuntu user, I switch to that Ubuntu user, so when I have the default command executed in this Docker container, it's run as Ubuntu. A lot of sysadmins, a lot of environments don't really like you to have root privilege inside of the Docker container, and it can also make moving files back out of that Docker container once it's finished running more difficult because they get owned by root. So you want to have things generally run as a non-privileged user whenever possible. Another important point here I should point out is I've mentioned Docker image and I've mentioned Docker container. So a Docker image is really the sort of flat file, the non-running image that can be moved around from server to server. A Docker container is an instance of that image running in memory and actually executing. Okay, so at this point, I've created my Docker file, which allows me to create a Docker image. Let me just show you how to actually do that. One note that I want to point out before I do that is this tag string. So the first part of it, what I'm trying to do is I'm trying to match what I'm doing locally for my development process with what it will ultimately be called once I publish this on Quay.io and Dockstore. So since I know that I'm eventually going to put this on Quay, I know that the beginning of my tag starts with Quay.io, and then this matches my GitHub repository. So this is my organization, and this is my Get repository name. And the final part of it is a version tag. And so currently, if I look at the releases of my BAMstats tool, I'm currently up to 1.25-4. That's currently what's released in GitHub. That means that my development is currently happening on 1.25-5. So if you look over here, when I actually do my Docker build, I'm actually calling this tag 1.25-5 because I'm working on the new version of this tool. So let me just go ahead and execute that. Okay, so that was pretty quick, but it's because this is a very simple Docker image. And also, again, that caching. You can see it's using each of the layers of the Dockerfile can be cached. In this case, I just built this a few minutes ago before the tutorial started. So everything is coming out of the cache. That's why it's lightning fast. So you see at the very bottom, it says successfully built, and we're looking for that. And then I also just want to make sure I understand that this is indeed available on my local VM here, my development VM. So if I do this, I can see that I've previously developed version -2, -3, -4, and now I'm on version 5. And the reason it says 5 days ago here, it's just because there have been no code changes between -3 and -5. So it's using fully cached versions of those. Okay, so at this point, it looks like we have the version that we need locally. So now we can get along with testing the Docker image. And this is a cycle that you guys will be doing over and over again. You're going to build your image. You're going to test the tools inside of it, make sure everything is perfect. If there's any problems, you go ahead and tweak the Dockerfile. You can go ahead and rerun the build and wash, rinse, and repeat, right? So you're going to do this multiple times throughout your development process. This is such a simple tool that I'm really not going to have to do multiple rounds of testing here. So I'll look for my run command. Now I'm going to take the Docker image that we built and turn it into a running container. The -v parameter I'm going to come back to in a few minutes. The -it is saying that this is an interactive session. Run is telling me that I'm going to run this and turn it into a container. And the other thing to point out is bin bash. So I'm actually going to explicitly say when you run this Docker image and turn it into a running Docker container, the first command that you want to execute is bin bash. That'll actually drop me into a shell. Okay, so that wasn't very dramatic, but now we're inside this Docker container that's running. So my little virtual environment. So the first thing I'm going to do is I'm going to cd into the Ubuntu home directory. And you're going to see that I already have some files available here. So the tutorial says, download this 1000 genome spam file. Well, I already have that available. And the way that I already have that available is the -v parameter. So when I executed, what I was telling it is -v, which is mount, take the current directory. That was my directory that I had this spam-stat tool checked out on my Azure Ubuntu box, and mount it as home Ubuntu inside the running Docker container. And this is a really key parameterization of the Docker run. This is the mechanism by which you move data in and out of your Docker running Docker container. So if you're going to do some analysis, you can mount in a directory, has files in it, do some analysis on the Docker container, and then write the output files to that directory, shut down the Docker container, and those files still persist. So that's how I have access to this file that I previously downloaded. Okay, so at this point, I have a sample file. I'm going to go ahead and run the BAM stats wrapper that I created with that sample file. Okay, so this is just going to take a moment. And in the meantime, we can just look at what that wrapper is doing. It's basically constructing a Java command because BAM stats is a Java-based tool. And it's providing two parameters. One is the amount of memory it should use, and the second is the BAM file that it should use. It's then going through some steps to ultimately create a BAM stats report zip that includes HTML files and whatnot. And you can see here, we now have a report. And if I look at what that report looks like, it's going to be a series of HTML files that just show you a nice plot of coverage depth. But what happens when I go ahead and exit my Docker container here? What we're going to find is that the file is actually in this directory now. So that shows you an example of running something in Docker, mounting in a shared directory, and once the Docker container ceases to exist, that shared directory has the files in it that have been created inside that Docker container. Okay, so we're half an hour in, And this is kind of the point where most people take their Docker development and basically stop. You could stop here, right? So I've shown you how to create a Dockerfile, to use that to build a virtual environment that you can run tools in, add tools to that environment, run tools there, pull data back out of it using -v. You could essentially send around your Dockerfile to your collaborators, and they could use it to build a Docker image and then to run it. The trick here is that you would have to tell them how that whole process works. You'd have to describe to them how to call BAM stats, how to execute the Docker run command. So that's really where CWL comes in. It's a mechanism by which we can start documenting, in this case, how to run the BAM stats tool in a human and machine readable way. So I'm going to move on here now to actually creating this Docstore.cwl that describes just how to do that. So in this example, I'm using the common workflow language. Hopefully in a future tutorial, I'll show you the same example, but with WDL, which is an alternate sort of descriptor language that we're supporting on Dockstore. But I'm going to walk you through now what this Docstore.cwl is all about and how it works and what are the contents. Okay, so if we look over here, by default, the name is Dockstore.cwl. You can actually customize that yourself. When you register on Dockstore, you can change the default path. But by using Dockstore.cwl, it just automatically picks it up. So the first part is, the most important thing is it's telling you a little information about the ID. But the most important thing to point out is it's telling the specific version of CWL. So this is important as CWL matures and really reaches its 1.0 release. We want to have good documentation to say explicitly what the CWL, what version of CWL this CWL was written towards. And that'll help us in the future to have a migration path as we have different versions of CWL, hopefully being supported by different versions of the runner. The next thing I want to point out as this description is actually read by the Docstore eventually. So you can actually use this to pass in description information. If we look over here, Docstore actually supports Markdown. So I actually can do formatting within this and do a multi-line description using this bar here to indicate that it's a multi-line. So that's really nice actually, because you can put images and links, and actually in this case I'm showing how to do a shell sort of formatting, pre-formatting. The next thing in the Dockstore.cwl is a little bit of information about the author, and this is a bit open to interpretation. So is the author the person that makes the CWL and registers on Dockstore? Is the author the person that makes the Dockerfile and creates the Docker image? Is the person the actual original author of the tool? So this is partially open to interpretation. I'm biased towards the person that registers it on Dockstore, so this person can actually receive questions from the community about this particular tool on Dockstore. But I could understand people making the judgment call in a variety of different ways there. There's also a DCT contributor tag that can be used, and I think that's a great way to actually flesh this out and make it clear that there are multiple contributors to this tool. The next section describes the requirements, and this is interesting because we actually are linking it up to the exact name of the tool that we built and pushed to Quay.io. So in this case, you can see the example is -3, but if I look over here, again, I'm working on the -5 version. So I need to make sure that this Dockstore.cwl links up with the correct version that I'm currently building. The next section talks about hints. So these are resource requirements, and this is the place where you would document how many cores, how much RAM, how much disk space. Not every CWL execution environment is going to support this, but this is the sort of way that you can describe that for environments that do. The next section is inputs. So this is where I can define those two inputs that the BAM stats script needs. So the first is mem, so the amount of memory required. And you can see I can organize the position, give some description of that, give a default value, give a type. These inputs and the outputs that come, they're actually used to construct the command line. So used to actually just construct the way that the BAM stats wrapper script that I have is executed. The next input is a BAM input. Again, you can just specify the file type, a description. What's interesting here is this just says it's a file, but we know in genomics we have many different file types. So in this case, I'm using the EDIM ontology to specify that it is a BAM file. So this format tag is really important because it allows us to start talking about not just a file, but the type of file. And finally, I'm indicating that this should be position 2 in the command line that's constructed. Many tools require a -- prefix before the parameterization, and that is an option here as well. You can use the prefix keyword right under position to indicate if it needs a -b or -g or some other parameterization before the actual content. And then finally, outputs. So outputs here, what's happening is when you run something through CWL, it assumes the outputs are in the local current working directory. So this provides a mechanism by which I can say this particular file in the current working directory should be collected after execution and exported from the Docker container. And again, I use EDIM ontology terms here to specify it's a zip file. And then the final item is the command that actually will get used. In this case, it's going to be bash, and then my bash script called bamstats that's in user local bin. In this case, what's happening is this command is used together with the inputs and their positions to construct an actual command at runtime. So now that I've defined what the tool is inside of this Docker container and how to execute it, let's go ahead and test it locally. And again, much like creating a Docker, the local test is going to be a sort of multi-path. You can, or multiple round of testing. So you're going to test locally, fix problems, test locally again. In this case, I've already downloaded the sample BAM file, so I have that ready to go. And I've already created a copy of that in the temp directory, which is going to be the path that I use. Furthermore, I've created a sample configs.local.json. So when you run something through CWL, the parameterization is a JSON file, and that's exactly what we have here. So I have BAM inputs, which matches the declaration of the CWL, and I give it a full path. And then I have the status BAM stats report, which matches the output, and I give that a complete path as well. Notice I'm not mentioning the gigabytes of memory. I'm just allowing it to use the default value there, which is 4. Okay, so the other thing I wanted to point out here is while CWL knows nothing about remote files, it just knows about local file paths. Since we're running this through the Docstore helper script and command line, it actually does know about remote paths. So the Docstore command line, there's more documentation on our website, but it understands inputs from HTTP, HTTPS, FTP, and S3 URLs as well. And we're going to add more in the future. And it also supports S3 URLs, FTP, for upload of those files in addition to just local file paths.
Does that mean that the Docstore is going to get those files from those URLs, or you're going to give those URLs to your tool?
It means that it will get them for you and stage them, and I'll walk you through the life cycle of that Docstore command. Other environments that execute CWL may have other restrictions or other sort of schemas that they support for download. The CWL core tool only understands local file paths, so that's why Docstore downloads it, changes the path for you, and provides the updated JSON to the CWL tool, which then executes it.
Can a command inside a Docker instance access a URL outside of it?
Yeah, basically a Linux environment. So if you want to pass in, instead of passing in a file, you just want to pass in a string that's a URL. That dutifully gets passed down to your tool, and then your tool can do whatever it wants. Okay, so let's go ahead and run this thing. I'm going to use the Docstore command line since it provides a nice interface. I'm going to specify here that I'm running the Docstore.cwl that I just showed you. That's a local entry, right? It's a local file. It's not on Docstore remote. And then I'm going to give it the sample JSON. Okay, so I'm just going to go ahead and start running that. Now, to answer your point more thoroughly, this is the life cycle that the Docstore command is using. So in the first step, it's going to look at your sample JSON. It's going to do any file transfers that it needs to a local working directory, and then munge the JSON to have the correct path to it. It's going to pull Docker images, and then it's going to run the CWL tool command that will execute that CWL descriptor and put together your command and actually execute it in Docker. And then finally, the Dockstore command line picks up, and anything that you specify that will be a remote URL for the output, it will provision it back to the output. Again, in this example, we're just using local files directly. So it's still running. It should take a few minutes. Well, hopefully not a few minutes, but. Okay, so the other thing I want to point out is you can add debug to it, and that'll give you a ton of information, including showing you the specific CWL tool commands that are being used. And the other thing to point out is Dockstore creates a local working directory called BetaStore, and that's its current directory where it'll pull files in if they're remote, mount them in, and that sort of thing. So you need to be aware that the current working directory that's being used by the Dockstore CLI creates this directory. So you want to make sure that the location that you're working in has plenty of space. If you're going to run a whole genome workflow using this tool, and it's going to download the 300 gig file, make sure that this file path is not in a directory that only has 20 gigs. Like it's going to fail at that point. So you want to be careful of where you're executing this to make sure you have plenty of space. And we saw that what happened is it provisioned the final output to the correct destination. So now if we look under /temp bam stats, we see the file is actually there. Okay, so at this point, we've built the Docker, we've tested it, we've built the CWL that goes with that Docker, we've tested that it all works. Now everything is working, so we need to go ahead and release on GitHub. So this is going to release our source code, this is going to release our Dockerfile, this is going to release our Docstore.cwl. So I'm just going to go ahead and, first of all, check my status. Okay, so I'm all pushed to develop. Now I'm going to go over here and say 1.25-5, 1.25-5, and I'm just going to go ahead and release it. So we now have a 1.25-5 released on GitHub. Okay, so in this, the next step is to allow Quay to do the same thing that we did when we did a Docker build. So Quay is going to automatically do that for us, which is quite nice. I'm not going to walk you through the entire process of setting up a new repo because this repo, it already exists. I already have this repo created. So I'm not going to be able to create it from new, but the process I would use is create a Quay account, log into it here, do a new repository, and this is where I would put the Docstore tool path. So if I look back here, it's going to be this matches. I would indicate that it's public because we currently only support public entities on Dockstore. And then I'm going to say that it's linked to a Get repository. So the tutorial has more information that walks you through this whole process. I'm not going to hit create here because again, I don't want to, I won't be able to create this repo because it already exists. What I will show you though, is I will show you how to do build triggers. So this is my repository, Brian D. O'Connor, Dockstore tool BAM stats. I can actually go ahead and create a new trigger for the 1.25-5 release. So in this case, it's a get push. We'll go over here and load my repository. And the whole reason we're doing this is we want Quay to build our Docker image and to host it, which they provide for free, which is fantastic. So I'm going to scroll down to my repository. This one. I'm going to click Next. I'm going to match the new tag that I just put in there. So 1.25-5. I'm going to click Next. My Dockerfile is located in the root of my GitHub repo. And I'm going to create the trigger. So now any updates on this tag will result in this automatically building a new Docker image. And I can go ahead and run the trigger now. 1.25-5. And I can start building it. So now once this build is complete, I'll have the public Docker image for this tool available. All right, so with Quay building in the background, I'll move on to registration on Docstore. And this is actually the easiest thing to do out of everything I described. In this case, I'm going to log into Docstore with my GitHub account, and then I'm going to click on Manage Tools up in the right-hand corner. So I've logged in already as Brian D. O'Connor. Click on My Tools. And what's happening here is Quay.io is automatically associated with my account. So all the different organizations that I'm a part of on Quay.io are listed over here, and all the repositories that have a Docker image associated with them are listed within these organizations. So you can see for my personal one, I have a Docstore Tools BAM stats already registered here. And to publish it, I'm just going to click or unclick the publish link. So actually, that's all you have to do. Since we hosted our information on GitHub and built on Quay.io, it's all automatically taken care of for us. The only thing to point out is if you are using something like Docker Hub, it is a more manual process where you have to manually specify because Docker Hub doesn't have an API for us to use. But it is still possible to use Docker Hub hosted files. You'll notice, so if I click over here, you can see all the previous releases that I have. They're all valid according to Docstore. If they weren't valid, the #1 reason why is because you've customized the Dockerfile location or the Docstore.cwl, you've called it something else. So this is the place where you can customize that and then go ahead and just refresh. With that, we've successfully registered on Docstore, and we can go ahead and share that with other people. So that's simply sharing the path, the URL with other folks. And what's cool about this is once you give them this link, they can go and see your GitHub, they can go and see Quay.io, they can use various sharing tools here, they can get general information. And I like to include a sample run of the tool, like showing people how to run the tool, which we'll walk through in a minute. They can see the various versions that are available. We even support labeling, so you can tag the tool. And it also allows them to see the Docker file, which we pull from GitHub, and the descriptor, which we also pull from GitHub. So it's a really nice way to share with other people and show them how to run your tool using the Docstore command line like we just did. Going back here, now that you've done that, you can follow the same basic process. So here's an example of, instead of using a local file, I actually can go ahead and, as a client of Docstore, I can use the Docstore command line to retrieve the CWL associated with a particular version of the tool. I can then retrieve a JSON file that's available for me to fill in. And you saw an example of what that looks like. This will actually generate, if I run this, this will actually generate, oops, an empty JSON where I'm going to fill in my parameterization. And then finally, you can use the Docstore tool launcher to, unlike the previous example where I was showing you how to run a local one, this will actually run one remotely. So I'm just going to go ahead and that's going to run it from Docstore itself. So at this point, we're pretty much done with the tutorial. Of course, it can't be a perfect tutorial. I almost got to the end without an issue, but clearly there's something going on here. We'll come back to that in a minute if we have time. Some tips and tricks. Actually, before I go into the tips and tricks, I just want to go ahead and look at the questions that came up. Let's see. So this is a good point. So there was one question here about Ubuntu users or using a different user type. So this is an issue definitely with Docker in general. If you're not using the Ubuntu user, using root, you write some files out that can only be read by root, and then you try and access those files as your own non-privileged user. So that's something that there's a variety of people working on solutions to that. One way is that as administrators in your system, you could basically pass in a user to Docker and force that user to be used for the Docker commands that are run inside. So that's one potential option. The other way is this is less of an issue when you're running Docker within VMs that you control. So if you control the VM within that's then running the Docker container, you can go ahead and sudo and change ownership of files that come out of the Docker container. So I'm not saying that that's a perfect solution. That's definitely something that a lot of people are looking for a better way of managing. Let's see, other questions here. So I think Dennis already answered that question as well. So you can see the answer in the question and answer. And then Dennis also answered the question about optional inputs. So CWL has a syntax for optional inputs. This is a good point that Dennis brings up, though, is we're in draft 3 right now, and draft 4 will be released hopefully in the next month or so. It's being worked on. You can access it on the CWL website. So that may change some things, but I'm hoping draft 4 will be the final draft before CWL reaches its 1.0 version. Okay, so I think we got through the questions here. Just going back to the tips and tricks, some things to know about general Docker tips. Sudo in the Docker command. Have your sysadmin, if you're using a shared system or when you set up Docker, make sure to follow the instructions that don't require you to use sudo when you do a Docker run. It's just more convenient that way. The other thing to keep in mind is to avoid using sudo inside your Docker-based tools and scripts, and then try to use a default user like Ubuntu when using Ubuntu to make it easier to access files as they come out. And again, try and avoid using root because of that issue with ownership of files coming out of the container. Again, if you're running Docker inside a VM that you control, you can always do sudo. The other thing that's a real big gotcha is Docker inside of Docker. It is possible to have Docker call and launch other Docker containers, but we tend to avoid that because it adds a lot of complexity. And there can be issues when the version of Docker inside the container calling a version of Docker outside of the container. If there's mismatches, it'll actually crash and not work. The other thing I've noticed is avoid changing the host name or messing around with etc hosts. Docker controls etc hosts inside your Docker container, so it will interfere with this process, so don't depend on that. The other thing that we've noticed when working with Peacock Docker containers is try to avoid designing your Docker containers to take a directory of input files. Try and be explicit about the inputs. And that's because it becomes very difficult. CWL draft 3, for example, doesn't support directories as inputs. Draft 4 probably will. But it becomes very difficult to document a directory structure for an end user versus if you explicitly say it takes these 4 input files. And the other tip is keep your Docker images small. If you put all the dependencies and especially reference files for genomics tools inside of a Docker image, it can get quite large. So general CWL tips. CWL tends to lock down directory structures. So really keep the temp directory and the current working directory for the outputs of your tool as the locations that you read and write to. Try to avoid reading and writing outside of those directories. I already mentioned the data store directory as our temp directory structure for the Docstore CLI. It's very important that you're running this within a directory that has plenty of space. The other thing to point out is you need to, in CWL, you're collecting the outputs from your tools or workflows inside the Docker and moving them essentially to the outside. So you basically need to make sure that your tools that you're calling, whether it's the tools themselves or a wrapper script that you write, are properly staging your files to the current working directory so CWL tools can find them and move them back out of the container. And related to this, it oftentimes is easier to write a wrapper, like I did with my BAM stats wrapper, to handle the parameterization coming in from CWL that is command line oriented with something else. If your tool takes an ini file, for example, to run, oftentimes it's easiest to have a simple wrapper that will handle that. I've already mentioned the large data set issue and the temp directory issue. The other sort of advanced tips is you can have a Docker image with multiple tools in it, and you can register them via different CWL. So you can have one tool, one Docker image that has many things inside of it. You can also have a Get repository that has multiple CWL, so you can register out of the same repository multiple times. Again, this requires the customization by hitting the versions and editing. So that's the key place that you use if you're going to use the same Docker image multiple times or use multiple CWL out of the same repository. You can manually register them and fill out their information. And then finally, we didn't cover WDL, but WDL is also possible. And we didn't cover workflows, but workflows can also be registered on Docstore. That's a new feature. So in future tutorials, I'll talk to you about WDL, and I'll talk to you about registering and running workflows as well. So at this point, I want to go ahead and go back to my presentation and just thank all the people that have worked on this, and also talk about what's next. So if you need to reach me and ask me questions, that would be great. Email me at my Gmail is probably the best way to reach me. If you find bugs in Dockstore, we definitely want to hear about them. So let us know through creating a Dockstore issue on GitHub. You can chat with us on Gitter. And also, if you're using a particular tool in Dockstore, there is a discuss feature. So you can go ahead and add comments and questions to the individual tool. And hopefully the author of that tool will be monitoring that discuss so they can actually see your comments there. So that's a great way to provide feedback. Again, I'm going to have future tutorials. There's a workshop at ISMB that's coming up in 2 weeks' time, and then we'll do an advanced tutorial. Acknowledgments. So Docstore was founded and is being funded by the Cancer Genome Collaboratory at the Ontario Institute for Cancer Research, and is being developed in collaboration with the GA4GH. So that's the Global Alliance for Genomics and Health. At OICR, the core development team for Dockstore is Dennis and Solomon, and we've had a ton of help through various co-ops from University of Waterloo. So in addition, I want to thank folks at Santa Cruz, the Peacock Technical Working Group, the Broad, Jeff, and Curaverse Peter, who are my co-chairs for the Containers and Workflows task team, which is part of the GA4GH. So at this point, I just want to thank everyone very much for attending, and let us know if you have more questions. I'll go through any other questions that appear on the Google Hangouts on Air and add them to the final slide here of the slide pack, where I've answered several questions that came up during the last tutorial. So again, thank you very much, everyone. Thanks for attending, and I'll put future tutorials on the Peacock mailing list, the GH mailing list, and various other places to let folks know as we do future tutorials.